Number one, the observations of the stars. In the northern hemisphere, the stars rotate counterclockwise. In the southern hemisphere, they rotate clockwise. This makes absolutely no sense on the pizza land. Why would the sky be rotating in opposite directions just depending on where you're standing? Just depending on where you're standing. How are you getting the sky to rotate in opposite directions depending on where you're standing?
Let me show you something. Dave says that it depends on where you're standing,
Just depending on where you're standing.
that you'll see different rotation. That's not true. Let me just show you that stellarium here. So this is showing us in St. Paul, Minnesota. So I'll zoom out. So we're right there in Minnesota, and we are looking north, and I'm just going to show you what we see. We see anti-clockwise, right? Okay, let me reset it and change our view a little bit so you can see Polaris right there. So the whole sky is going east to west around Polaris. Okay, so what happens if I turn around? What do you think would happen? So we're facing south now. Let's see what happens. Oh, they're going clockwise now. And we're standing in one spot. So it doesn't matter where you're standing. Let's look to the north. Let me show you something. Let's go to the very south part of the world. Whoops. Very south tip of Argentina or whatever. Okay, so we're in Chile, okay? So we're still looking north. And Dave's saying that if you stand in the southern hemisphere, you see a different rotation than you do in the northern hemisphere. Well, I'm going to show you what we actually see, because stellarium is accurate. So here's what we see standing on the southern tip of Chile, looking north. They're going anti-clockwise. Anti-clockwise, right? Okay, what happens if we turn and look south? Then what? They're going clockwise. And look at this. They're going around. So when you look north, let's go somewhere. It doesn't matter where you're standing.
Depending on where you're standing.
Anytime we face north, we see anti-clockwise. Anytime we face south, we see clockwise. And you know why that is? Because all the stars, no matter where you are, they're all rising in the east. Like this. See, they're rising in the east. Now, if we were to go to the equator, see how they're going at an angle here? If we were to go somewhere on the equator, which I don't know where the equator is. Right there. Close enough. Altamira. I don't even know where that is. Okay, we're looking east. They should be rising kind of straight up and down now. See that? But the reason why you're getting different rotation is because if you're looking south, they're rising on your left-hand side, right? And they're setting on the right-hand side, so they're going to be going clockwise. Well, they're all doing one motion, because if we look north, okay, we're looking north, they're going to be going anti-clockwise from anywhere on the earth. That's because they're rising in the east and setting in the west, so they should be going down from here. Yes. There you go. It's actually quite simple.
Let's start with there. How observable is that? How does that fit with
Yeah,
your
this,
default?
this is what always happens. Instead of providing evidence that the surface is curving, you're saying, well, but if it's
No, no,
not,
no,
then
no,
how
no.
does this happen?
No curved surface. You said the default
That's
position, flat
mhm.
plane. I'm asking you on
Yeah.
your flat plane, explain the observations of the celestial sphere. In the north, you get counterclockwise rotation. In the south, you get
Mhm.
clockwise rotation. Explain that to me on your default flat plane. Explain it.
Yeah, so the counterclockwise and clockwise direction is super simple. It's based on looking different directions. Your better question is why does it go around a singular
N-
point, is
No,
what you're trying to say.
no, no, no. I'm
Yeah.
asking about the direction. I'm asking about the direction.
It just looking
Counterclockwise
opposite
versus.
directions would make them go the opposite directions. They
Would it
all go
though?
east
Would
to
it though?
west.
If you put a
Yeah,
clock
literally.
on your ceiling, which way can you face to make the hands go counterclockwise?
Austin just explained it to you very clearly. All of the stars go east to west, Dave. Anywhere on Earth. If you turn around, look south, they're going to be going clockwise. If you turn around and look north, they're going to be going counterclockwise. Doesn't matter where you're standing. Go anywhere. That's how it's going to be. Austin is explaining it to you, and you're not hearing him.
Tell me
Yeah,
which way you can face.
not analogous. The stars
No, it
drop
is
and,
though.
and
It is though because
the stars
the hands on a clock
you
go
don't get it.
clockwise, right?
You
The
don't get
hands
it.
on
The
a clock
stars
go clockwise.
drop due to perspective, so we're actually looking out towards them, not directly up.
Well, it
Did you know
depends on
that?
your latitude, right? Depends on your latitude. If you're
So
at
do
the
you
equator,
agree?
they're going from horizon to horizon.
Wait, do you
You just
agree
look
that
straight up.
if I was looking out and something was spinning one way and then I looked at it from the other direction, it'd look like it was spinning the opposite
No,
way?
it
Yes or no?
wouldn't. It wouldn't.
Okay,
That's why I
so
said
Yeah, Austin, I don't think he's going to get it.